And good morning, everyone. My name is Assunta Marrocchi from the University of Perugia in Italy, and I am the coordinator of POLYMEER project. And in these few minutes, I will focus on the technical contribution of the University of Perugia beyond my role as coordinator. Let's say that I would like to start with two parallel realities. On one side, we have three high-demanding sectors which still depend heavily on fossil-based plastics, which has already been somehow said, no? Here we have mulch films, for example, that can remain in soil for decades. We have car seat fabrics, for example, that are made almost entirely from fossil polyester, and also pallet stretch films. This is still mainly polyethylene or polyvinyl chloride. And we have bio-based alternatives that exist, of course, but broad market uptake is still limited because of performance, cost, and scalability. At the same time, we have that the European brewing industry generates around 8 million tons of brewer spent grain every year, let's say, and throughout the year. Most of it is sold at very low value as animal feed, for example, and some is still disposed of. However, BSG is rich in cellulose, arabinoxylans, that is hemicellulose type, polysaccharides, and lignin, and exactly the components we may need to produce bio-based polymer. So the resource is available. What has been missing is a scalable and green process to separate this fraction and convert this fraction into polymer-ready building blocks. So this is the problem we are addressing. So our process starts directly from wet brewer spent grain as it comes from the brewery. That is that we don't dry it, avoiding a major energy-consuming step. And we fractionated it using aqueous chemistry and mild temperature, nothing above 90 degrees, and recover cellulose, hemicellulose, so arabinoxylans to be more exact, and lignin. And each fraction follows a different conversion pathway. This is like the big picture of the whole project, of course. And from them, we produce building blocks for three polymer families, targeting mulch films for agriculture, stretch film for packaging, and textile for automotive application. And let's say that everything developed downstream in polymer begins in the first two steps, which are the activities of the University of Perugia. And for our team, this is at the same time a privilege, but also a big responsibility, I have to say. So we believe that our approach is distinctive for 4 reasons, we could say. First, it applies green chemistry from the beginning to the end. So we use safer solvent, recyclable catalysts for the conversion of the fraction into the polymer-ready building blocks, mild temperature, and waste minimization during all the process of the extraction and conversion, specifically in the case of the University of Perugia. Second point is that circularity is like built into the applications because the BSG-derived stretch film can return to the brewery. For example, we have our partner, which is Birra Peroni, acting both as feedstock supplier and end user, so to close the loop. The mulch film are designed to biodegrade in the field and realize nutrients, for example, And the automotive textile are designed for mechanical and chemical recycling at the end of life. So this is the circularity aspect. Third, the environmental benefit is measurable. We performed an ex-ante life cycle assessment, which is still under validation, but we already have an idea of how things are going, because processing of 1 ton of wet brewer spent grain can avoid like 80 kilograms of carbon dioxide equivalent. So also we have an estimation of the carbon footprint of our building blocks, which is between 49 and 67% lower than conventional fossil-based production. These are, of course, early stage figures, but the direction is really encouraging. And fourth, we aim for no compromise in performance. So in field biodegradability, for mulch film, intrinsic flame retardancy, for example, for automotive textile, and also mechanical integrity for stretch film. So bio-based should not, of course, mean lower performance. This is the aim. Let's say that we are now at month 22 of a 48-month project. On the University of Perugia side, I would highlight two main results. The first is the BSG fractionation process. It builds on a patented protocol which was developed by our team before POLYMEER. Within the project, together with a DBPP partner, we have optimized several steps and explored also alternative routes to make the scale-up more sustainable. This is the key point. And we currently achieve approximately 90% of cellulose recovery, up to 90% of arabinoxylan recovery, both as native polysaccharides and also with simultaneous functionalization, and around like 80% lignin recovery. So all this is achieved in aqueous media and below 90 degrees. So scale up is currently underway. And the second result on the right side is the building block library. So far, we have synthesized and characterized like 20 bio-based building blocks in 2 families. And the first family includes lactone monomers for bio-based polyesters. The second includes functionalized biopolymers, which can be used as precursors for vitriners. And the lactone library, this is a very important thing, combines aromatic structure from lignin with aliphatic structure from the polysaccharide fractions. And this diversity allows us to tune the material properties for different applications. And our next step will be selecting the most promising candidates for scale-up and validation in the 3 targeted sectors. So to come to the end, POLYMEER brings together 14 partners across the full value chain, from green chemistry and pilot scale production to life cycle assessment, market exploitation, industrial end users, and so on. However, 3 types of connections could help us move forward. The first one is agricultural cooperatives, for example, or horticultural producers, which are interested in real field testing of our biodegradable mulch film with built-in nutrient release within the next 12 to 18 months. The second is the packaging company in the food in sectors other than brewery, or also breweries, of course, willing to share their technical requirement and also explore bio-based vitrimeric stretch film as a future sustainable option. And third one is research synergy with CBE JU or other European projects working on lignocellulosic biomass valorization, mostly like green processes for lignocellulosic biomass valorization. And this could include, for example, exchanges of research approaches, joint publications, future collaborations, and so on. So with this, I thank you for your attention, and I would, of course, thank the organizers for inviting us in this webinar, and also the partners of Polymer. You can see represented here the logo, and of course the CBE JU and the European Union for funding. Thank you.